Okay, so I think everything is ready. Uh, just confirm to with parents that I'm gonna be late. Since I have a bit trouble in my connection. Luckily that I just 1 minute away from the pointed schedule. Today is 6:31. Uh, yeah, once I joined the meeting, the student hasn't yet joined the meeting. Probably that the kid is still having a dinner. So yeah, let's just wait for the student to come. Okay. Halo, good evening, Widi. Hmm, good evening, Widi. Probably uh,
Oke,
student still having dinner. Ah, halo
oke.
Ibu, selamat
Halo,
malam.
malam.
Kaget kirain saya ada kok masalah di koneksi saya.
Kenapa?
Kirain saya ada masalah di jaringan internet saya tadi, Mas. Oh, kok nggak ada
Ah,
suaranya?
saya salah pencet kayaknya. Tunggu sebentar ya, Windy masih mandi karena dia masih anu tadi melayangan.
Oh, halah. Oh iya, sekarang musim panas emang anginnya lagi enak-enaknya sih ya. Hmm.
Dia
Nggak apa-apa, Ibu,
nganterin,
nggak apa-apa.
nganterin kembarannya, tapi akhirnya pulang sekolah langsung pergi.
Ah, ibu, mohon maaf Ibu. Saya ini kan Muslim, kebetulan saya belum sholat maghrib. Nah, jadi saya nanti mau minta tolong sama Ibu. Jadi saya menitipkan tugas ini untuk coba dikerjakan Widi dulu. Nanti setelah kita selesai, saya selesai sholat maghrib sebentar ya Ibu.
Hmm.
Nanti kita bahas ini. Kebetulan kemarin materinya tentang ini Ibu.
Oh
Jadi
gitu.
sekaligus untuk kita mengulang kembali tentang materi aljabar yang telah dibahas sama Widi di sekolah. Gitu.
Oke, oke, oke.
Ya, jadi mungkin sebentar ya Ibu. Soalnya kebetulan azan Isya sebentar lagi. Saya belum sempat sholat maghrib. Mohon maaf Ibu, sekali
Ya,
lagi.
ya, ya. Oke, oke.
Eh, ya Bu ya, nanti kita bahas sama-sama. Makasih Ibu.
Ya, sama.
Really? It's really here. Ah, halo Widi. How are you today?
Good.
Alhamdulillah. How is school?
Yeah, good.
What was the last topic being discussed at school? Are you guys still talking about the algebra or are you moving into the
Still
next
algebra.
still algebra? Hmm. How do you think about the algebra so far?
I mean, it's like not that same, but in like what we're learning right now, we're learning about like the shapes, and then in my school we're like learning to like substitute like what you said. It's like um changing like the words or the letter into like the number, like the signs.
I see, I see. Just the area of the topic was not about the shape, right? It's
Yeah.
different thing. Yeah, it's different thing, but actually the concept will still be the same. Okay. Let me try to see as well. Your mother actually sent me about uh your book that is currently you use. Oh, hi, by the way, sorry that I was having my prayer previously. So I let your mother to know this that I actually gave you some kind of exercises just to know your understanding level about the algebra itself. Uh, while you are waiting for me, but I think you just been there, right? You just finished your shower.
No, I actually I already finished the questions.
Ah, I see. Cool, cool. That's awesome. Okay. Hmm. Hang on. Let me try. Okay. Let's try to check whether your answer will still be the same. Okay. Now we have the rectangle as well, the triangle, right here. Okay. In my opinion, that the first question is nine. The answer for the first question is nine. And then the question number two would be, I believe, 24/7 divided by 4.5. Okay, that I will put it later. Okay, so what about you? The answer.
Um, so at first for problem one, um, I thought of eight, but and then and when I read it again, it was nine, so I wrote nine. And then for the problem two, if it's like nine times three equals 37, so I wrote three.
Sorry, for the number two, it is.
For me, it's three because it's nine times three equals 27, I think.
Oh, you didn't put the halving in here, right?
Halving. Oh yeah, I half.
Yeah, the half.
I think it's um. Wait, let me calculate.
Let's try it again. Why do we put the half here? Since we are talking about the triangle, right? The area of triangle is the half of its base and height. Okay.
So is it wait, is it nine times? So it's six. I think six.
Six.
Is it
Hmm.
six? I don't know.
We already noticed the height is 9 meters, right? We already know the area of the triangle. So it's basically the thing that's only left for us to find is the B or the base itself on a triangle. how- Let me try. The base refers to this at the bottom. Ah, this is B. Okay. Since B began with the multiplication, means once we need to find the B itself, we need to move the H, right? As usual. As usual, it changed the identity to the division. So 24/7 divided by 9, right? Since it moves, you're already correct in that part. It's equal to the half of the B. Okay. Now, 3 is actually the answer for 24/7 divided by 9, right? But unfortunately, this one refers to the answer of the half of the B, right? Now, how do we actually find the B? Is remember half is equal to a division, right? So I can write it like 3 is B divided by 2. Ah, since B multiplied by 1, here would still be a B, and it means B per 2 or B divided by 2. Now, if we are about to find the B, we move this 2 into the substitute. We substitute the B at the 2 here at the bottom to the other side. Since it began with the division, now it is 3 multiplied by 2. It's B. So B is 6. Do you have the same answer as I do?
So yes, because like I just said, like in the first place I was wrong, and then when you said it's wrong, so I calculated into six.
Ah, correct. I think the concept is already on the place. Probably it's just because that you need to get used for the formula itself since it is about the shape we are talking about. For the triangle, it's always the half of the base multiplied by the height. Okay. Now, I believe the problem one was that easy for you, right? It's quite straightforward for you to move the L, move the 8 into the another side just for you to calculate the L itself. Is that correct?
Yes.
Yes. Now, let's try to have this now. If let's say a rectangle has P 30 meters, remember there is a differentiation between the P and the area itself, right? P is basically on the outer layer of a shape, meanwhile the area is the inside layer of a shape. The A refers to the area. Now, we need to find the L and the W. Ah, so how do you think it will be resolved? Let's try it.
So I think the easiest part for to figure out the area first. So 56 is 8 times 9. Eh, 8 times. Wait, is it 8 times 9? Is 9 times 9 times 6 or 8
9
or 8
times
times 7.
9 times 6 would, I think
It's
9 times 6 was
oh,
54,
it's 50.
right?
Oh, yes. Yes. Okay, so
Yeah,
8
so
times
it's
7.
it's excluded. Okay,
And then
would it?
for the perimeter, it's just 8 for one of
Mhm.
the length and width, and 7 for the
Ah,
side.
yeah, I got what you mean. So basically, you put the analogical between the length and the width for the rectangle itself. This is correct. This is correct actually. Why I can tell you that? Since the perimeter of the triangle is 2 multiplied by the length plus width, right? So as long as we find the combination between the perimeter and also the area with the same number, we actually already figure out the answer. Okay. If we put L is 8 and width is 7, the area would be 56, like you said. And if, let's say, the same number goes to be calculated as part of the perimeter, it means that 8 plus 7 is 15 multiplied by 2 would be 30 meters. Okay, that's cool, that's cool. Now, bonus, if the length increases by 2 meters, what's the new area?
Both of the length is at the bottom side, right?
Yes, the length itself.
So the length is 8
8. Okay, you
is
already identified that.
7.
And then the width is still
Hmm?
7, right?
Yeah, it's
Because
still 7.
we didn't put any increment to the length, to the width itself. So what's the new area?
70.
8 plus 2, 10 multiplied by 7, 70. Okay, awesome. You already understand that. Okay, meters, square meter, 70 square meters. Okay, that's great. Now, let's try to tweak a bit from words to algebra. Okay, so the algebra, as probably you already learned at school, or maybe I taught you since the last week, it's only about trying to twist this and that. We call it like symbol variables or something like that. But sometimes the algebra is actually still needed for the kind of stories or contextualized context. Okay, it's about the the way that we are trying to writing relationship using variables. What is variables? Do you know what is variable?
Mhm. I only know it in science.
Ah, it's actually similar to that one. Variable is something that we are actually trying to recognize, right? For example, if talking about the rectangle, for example, we already know there are two kind of things we need to have to understand the perimeter as well as the area, right? The first one is the length, second one is the width itself. Now, what we call as the variable is actually this one. Length is actually the first variables. The second one is the width. So it's two variables. Okay, sometimes in a kind of story formatted exercises, sometimes people trying to tell you that not by saying the length and the width in the case of the rectangle, but trying to say that it is the variables. The same case happen as well when we are talking about buying things on the shop, for examples, right? There are things we need to buy. We call it book, we call it pencil. Book is the first variable. The pencil is also the second variables. If we add another variables, let's say external things we didn't buy, on the shop, for example, the cashier, the total customers visited the store. The total customer visited the store is actually something that we also can call as the variable, right? It's something that trying to have the connection. Why the algebra is talking about the relationship? Because like the example of the rectangle that we've been learning until this time, we're trying to find what's the relationship between the length and the width in terms of the rectangle. And we already figure out that these two variables are needed for us to identify the area as well as the parameter, right? That's what we call the relationship. So the formula, the equation, is something that already, you know, being taught you at school or by me, is actually trying to tell you that there is actually a relationship between one or more variables. Uh, I put some of the examples right here, like the hall has length L. The width is actually 3 meters, less than the length itself. If you actually find this case, it's just as simple as like trying to translate, right? Trying to translate. And then if let's say I add follow-up question, once you actually find the width itself, which is 3 meters less than the length itself, right? Now you try to measure the perimeter of the hall itself, and it brings you to the numbers like 40. So what's the length?
Well, so the width is three, and so perimeter is like the outside, right?
Yes, correct. The perimeter is still on the outside.
Um, it's only four sides only.
Yes, for sides still.
So three, and the perimeter is 40. I think so 3 plus 3 is 6, and then wait,
Mhm.
then need to find what is 30, what equals 34. Hmm. Is uh, let me calculate.
Let's try that. We already know the perimeter of the hall. So what's the first formula we need to put here for the perimeter itself?
Peri um wait,
The
the
relationship
length um times two, I think,
length times 2, and then
and then the width two, and then and after that you add them.
with, okay, cool, cool. Length times 2 plus width plus 2. Let's try to segregate this. Okay. Now we already know the length is at the width is actually 3 meters less than the length itself. So how do we put it here? Let it stay. Let's assume that we don't put yet the perimeter. Let's just try to tweak the relationship between the length and the width itself. So the width is 3 meters. So I believe this one we need to translate, right? Since we already know the variable itself. So it would be still like length plus length times 2 plus length minus 3 times 2,
11 minus 3.
right? I change the width into the L minus 3. Okay. From there, then we put the perimeter. 40 is length times 2, length minus 3 multiplied by 2. Okay. We substitute the W, the width, with the L minus 3. Okay. Now, if that is the equation that we already tweaked, so what's the length?
So we have to like choose the cara. Or- So it's like I can just like all of the methods from there.
Hmm, correct.
So, it has to be like 34, right? Because it's like 6 and then 34 plus 6 is 40. So I think you have to find a number that when you plus it again by itself becomes 34. So it like I'm still going to calculate. Just wait a bit.
Okay, let's try it.
Hmm. Isn't it um what it's not um is it 17 the length?
Let's try to test put it like this. The length is 17. Okay, now let's try to put it into moment of truth. The perimeter is 40. We put it right here as part of substitution. And we already translate the width itself as L minus 3. Now, to begin with this, try to separate this first, since this is kind of like distraction for me. Okay, I draw two lines. I draw two lines and I write it like L multiplied by 2 plus 2 times of the L, right? Since I assume that this is the calculation as being written right here. L times 2 would be 2 times L. Now, this is the integers, right? Minus 3 times 2. How much would that be? Minus
What
3 times 2?
3 times 3 times 2. Terus so 3 times it's minus 6, I think.
Minus 6.
Yes.
Okay, minus 6. From this translated equation, we still have the same benchmark, which is the perimeter is still 40. Now, this 6 is minus, right? We need to move it to another side, which would change from minus to plus. Are you agree with me for that? Or maybe you have different opinion?
Minus, wait, can you repeat it?
Since it began with minus, right? When I move it to another side, it changes from minus to plus. Are you agree with that?
Wait, um, I don't know. But for me, like, I don't understand, like, how it would change, like, but so I think it's like the same because, like, I don't get how it changes. Like, I'm just like guessing.
Okay. One thing when we operate the calculation, moving numbers from side to side, it applies one condition only. It will change the previous status into a different one. So remember when we are trying to solve, hang on a bit. When we are trying to solve this, for example, we need to find B, right? We move this two as part of the division into another side, then it changed as multiplication, right? That's why 3 times 2. It applies the same with the plus and minus as well. So there are basic four operations: multiplication, division, plus and minus, right? And it actually correlates to each other. If let's say the statement of that calculation began with the multiplication, then when we move the number to the another side, it will change to division. That thing would happen conversely. If it begins with division, we move it to another side, it will converse to be the multiplication. Meanwhile, for the plus and minus thing kind of stuff, when we move it to another side, it will be reflected. Minus will be changed to plus, and plus will be changed to 6. Sorry, plus will be changed to minus. Sorry. Now, when we understand this concept, we actually could easily move anything as what we wanted, as long as it applies for the same rules. Okay. Now, since it these numbers is actually minus 6, where does the minus come from? It's actually from minus 3 multiplied by 2, right? Minus 3 multiplied by 2, that would be minus 6. And since we need to find the L, which is being linked to the multiplication, right? This L is linked to the multiplication. We need to simplify this further. The 6 is actually independent, didn't link to any L, right? And it began with the minus in integers. Now we move it to another side, it will change to plus. That's why I put it plus 6. Now, do you still have any confusion?
No.
No, okay. Eh, we change that. Okay, 40 plus 6. 40 plus 6 is equal to L times 2 and L times 2, right? Since we multiply 3 already with 2, and now we multiply L with 2 as well. L multiplied by 2 plus L multiply sorry, by multiply by 2. If this is the case, we already know at least this is 46 since it is 40 plus 6. Now, how do we find the L? How do you think about that?
The L?
Mm, we have two L's right there. L times 2 plus L times 2. So how do we find the L if this is the case?
Mm,
If
so
this
it's
is the
like
go on.
it's like the 40 plus 6. Do we need do we just need to like um is it like represents a shape or something?
It's actually still the same.
So it doesn't have to do anything with it.
I'm sorry.
So does it have anything to do with it?
Yes, there is one step left for us to identify the L, right? Because we only need to find the L itself. There are two approaches for this. right? First is trying to imagine, right? What's the possible calculation for us to be put? So we just like imagine, right? The nearest, the nearest calculation for us by saying this is there's actually a pattern, right? Pattern was still the same. L times 2 plus L times 2, right? So the first logic that might happen, might comes to our mind is actually this is actually the same numbers. This is actually the same numbers. So it could be something that we add will give us the 46. It should be 23 plus 23,
Okay,
right? Because
and
23 would be
so
46, right?
so just literally like divide it by two. That's it.
That's also the kind of approach almost there, but I would say that it's not the correct answer. Okay. Before that, let me try to continue this. If we try to put the analogy like this, we actually can find this is 23, but 23 is not the L. 23 refers to the L times 2, right? So even if we already imagine that this is actually the same numbers, we need to find like L times 2 is 23, right? 23. If let's say we are about to find L, we need to move these two from multiplication into division. So what's the answer?
23 divided by 2
Yes.
is l- it, can it be decimal?
Yes, for sure it's gonna be decimal because 3 is not the factorial of 2.
Is it 11.5? I think so.
Okay. 11.5. That's the nearest answer when we try to assume, we try to imagine. Oh, this is actually the same pattern, L times 2 and L times 2. For as long as I can try to combine all the numbers possible for me to be added later to be equal to 46, I get my answer, right? But how if I cannot imagine, I cannot assume because the numbers is quite big and it's really taking me a lot of time for me. Okay, let's keep it, trying to keep it there. The way that we can try to solve this is first trying to put the kind of curator, I can say this to differentiate. Since we already learned about multiplication should go first. Okay, if we didn't put any mark right there, right here, probably we could be slipped by 2 plus L first, which is not wise for us. It will also lead us to the wrong answer instead. Okay, since this is actually a pattern, L times 2, L times 2. I could call it as the same group. I can say this is the first group, this is the second group, right? It can be said as 2 times the L times 2. Are you agree with that?
Two times.
2 times of L times 2.
Yeah, because you like do it two times.
Yes, because I have two groups of L times 2, right? That's how I translate this. Now, I can move it. I can move this right. From the
Mm,
multiplication, I move it to another side. It will be 46 divided by 2. Am I right?
yes.
Yes. Now, 46 divided by 2 would be L times 2. 46 divided by 2 would be 23, right?
46 leave. Yes, 23.
Uh, 23. Okay, is equal to L times 2. Okay, if I try to find the L, then it means the 2 right here should move the another side to another side, and it changes from multiplication into the division. So it would be 23 divided by 2 is actually how I find the L. The same, right? 23 divided by 2, 23 divided by 2.
Yes.
So the answer would be the same, right? 11.5. That's that's the way we try to translate this, right? Because it probably confuse you. You try to find the L, but unfortunately there are two L's right here. How do we actually separate them or unite them into the same formula to then we could identify that variables, right? That's the way that I try to figure that out. When I see this as part of the pattern, right, and I try to use the concept of group, right, and it is actually similar to the multiplication, I can translate the algebra into my own story, right? Oh, this is actually two groups of L times 2, right? From there, I can tweak it. Is there anything you're confused about?
No.
No. Okay. Hang on. Okay. Cool. Now, one more thing. If let's say we need to paint them and it costs us 7,000 per liters, the whole need 3 liters. Okay. Now, how many it would cost us? So
So
the
each
area is
parameter that
perimeter is
is
already 40, right?
for 40.
Okay. 40 is the perimeter. If each liters would cost you 7,000.
So is it 7 times 40?
Yes.
Okay,
7
so
times 40.
let me calculate. Is it 200 IV?
Yes, correct. 280. Yes. That's the way we try to connect each relationship to each other, right? Previously, we tried to figure out what's the length of the whole, right? After we find the correlation between the length and the width, now we change the subject, right? We try to also find the correlation between the paint hole, right? The paint that we need to paint the entire hole and also the cost. It is also something that we can call as variability. So algebra is actually a wide kind of things, literally really wide. You can actually talk about a lot of things about variables, whether in science, in math, in social knowledge, it's also being called as variables. For example, you and your friend, the first variable is actually the person, you and your friend. Now let's add another thing. You and your friend trying to buy snack in the canteen, for example. You go to the meatball shop and your friend instead go to the castle shop just to buy beverages, right? You and your friend is actually the first variable. It's actually the customer, right? The customer of that canteen. Meanwhile, the meatball seller as well as the shopkeeper is actually the another variable. It's called the seller, right? You are the buyer, they are the seller. Those are two variables. So actually the context of the variables is something that can be used wide, very, very wide. And we try to find the connection by trying to translate them from textual into the equation. Like this, for example, when we use the rectangle cases, right? We try to translate what actually we understand from each variables and how it relate to each other into the calculation. Ah, so is there anything you're still confused about the algebra? Or maybe there's kind of other things that I don't understand about this at school.
No.
Feel free to ask me about it.
Okay.
Okay. So, uh, I think to not tomorrow. I think by Thursday, let's try to start our class with some kind of exercises like this, right? I will try to also add the kind of lesson that you're already being taught at school in case that uh you guys didn't go back to the shape again. Let's try to put the context, like for example, buying book on the shop, or maybe trying to put integers inside of that. And then you try to tweak that kind of formula into substitute, into variables, and then try to find the unknown variables. Okay? How's that sound for you?
Yeah, good.
Okay. How do you like it? Would it be the verbal, or maybe let's try to have kind of like written exercise like this, and then you try to solve all of it one by one.
Thing like this, that it's kind of fun.
Okay. Same, if that's the case. Okay, I think we did, that would be it for our lesson today. So I believe from what I understand is actually you already understand the way that you try to move around things, whether it's substitute or something like that. Just it is something that uh, I believe is also important to kind of remember what you already learned previously. Because somewhat in math, especially at school, I believe that it's something that is also important for you to call back, right? In case there is a new case, there is a new lesson to be learned today or maybe tomorrow, but somewhat it still have the correlation with the previous material. It helps you as well to have to sharpen your knowledge. Oh, this is actually something similar. Oh, this is actually something that actually have the correlation with the previous lesson, something like that. It would help you to fasten, to speed up the solution of the way uh you try to solve any exercises. Okay,
Okay.
cool. Okay, so I think that would be it. I believe you haven't ate your dinner yet. So
Yes.
see you on Thursday, Widdy. Bye bye. Have a good night.
Okay.
Dadah, Ibu.
Hai.